next chemical property of carbon compounds or the hydrocarbons, that is the substitution reaction. Substitution reaction of hydrocarbons. Substitution reaction. Now, what is substitution reaction? Reaction in which an atom or a group of atoms replaced by another atom is called substitution reaction. So, substitution reaction, usually methane, that is the saturated hydrocarbons or saturated carbon compounds. Example is given, methane. Methane undergoes substitution reaction. It reacts with chlorine in the presence of sunlight. In the presence of sunlight, methane undergoes substitution reaction. So, each hydrogen atom of methane is replaced by chlorine atom. Here 4 hydrogen atoms are there. Out of 4 hydrogen atoms, 1 hydrogen atom is replaced and in that place chlorine is substituted. So, the formula CH3Cl and the byproduct HCl, that is hydrochloric acid. What is this CH3Cl? This is called chloromethane. The product we are getting, chloromethane, that is the product of substitution reaction of methane. Only saturated hydrocarbons or saturated carbon compounds undergo substitution reaction. Methane in the presence of sunlight react with chlorine to give chloromethane with the byproduct hydrochloric acid, that is HCl. So, the reaction continues till all hydrogen atom of chloromethane or all hydrogen atom of methane is replaced by chlorine atom. So, we get number of byproducts here, number of products are obtained. This is called substitution reaction of methane. As we have studied, unsaturated carbon compounds, they undergo addition reaction and saturated carbon compound undergo substitution reaction. This also can be added while writing the differences between saturated and unsaturated hydrocarbons or the carbon compounds. Now, we will solve some of the questions related to this, related to the structures and the reactions. So, in that one question is, write the next homologous of write the next homologous of each of the following. Each of the following. That is C2H4 and C4H6. C2H4 and C4H6. Write the next homologous. Next homologous. So, what is this compound? This is C2H4. See the number of carbon atom, 2 carbon atoms, hydrogen, 4 hydrogen atoms. So, what is the relation between number of carbon atom and the hydrogen? Hydrogen atoms are double than the carbon atom. So, this is in the form of C2H4 is in the form of CnH2n, double. Number of hydrogen atoms are double the number of carbon atoms. They are in the form of CnH2n. So, this CnH2n, what is the name of this compound? This is alkene. This is the general formula of alkene. Here question is asked to write the next homologous of this. So, after C2H4, which is the next compound we are getting? That is C3H6. C3H6 is the next homologous after C2H4. 3 carbon atom, 6 hydrogen atoms. So, one more compound is given, C4H6. C4H6. See the relationship between number of carbon atom and number of hydrogen atoms. you multiply this number of carbon atoms, multiply by 2 or double the number of carbon atoms. When you double 4, you will get 8. That is, when you double 4, you will get 8. That is double. Double in the sense, it is in the form of 2n. You will get 4 2s are 8. Here 6 is there. So from 8 you have to subtract 2. 2n minus 2. So hydrogen atoms, the relationship between carbon as well as hydrogen. Hydrogen atoms are in the form of CnH 2n minus 2. We have to double the number of carbon atoms. From the answer, we have to subtract 2. So this is the general formula of which compounds? They are the general formula of alkynes. So in alkyne, one compound is given C4H6. What will be the next compound? Next compound will be C5 and H will be, you have to double this. 5 2s are 10 minus 2. 10 minus 2, 8. C5H8. After C4H6, you will get C5H8 in alkyne. So this is butane, this is pentane. So first compound is given, this is ethene. So the next compound is propene. We'll move to the next question. So question is like this. Write the name and formula of the write the name and formula. Write the name and formula of the second member of homologous series. The second member of homologous series. Second member of homologous series having general formula CnH2n. The second member of homologous series with the general formula CnH2n. CnH2n, that is the general formula of alkene. Question is, write the name and formula of second member of this homologous series. So in alkenes, first compound is ethene, second compound of alkene, of the family of alkene, second member is propene. Name of the compound is propene, and write the name and formula. What is the formula of propene? Propene formula C3H will be 6. C3H6 is the formula of propene. Molecular formula, name of the compound is propene. We'll move to the next question. So question is the molecular formula of A. The molecular formula. So this is a question. The molecular formula of A is C10H18. C10H18 and B is C18H36. C18H36. Name the homologous series to which they belong. Name the homologous series. Name the homologous series. Name the homologous series to which they belong. So see the first one. C10H18. C10H18. Now see the relationship between number of carbon number of hydrogen. There are 10 carbon atoms. How many hydrogen atoms are there? There are 18 hydrogen atoms. So how you will get this 18? If you multiply this 10 or if you double this 10, if you make double, so 10 double of 10 is 20. From 20 you subtract 2. 20 minus 2 you will get 18. So hydrogen, number of hydrogens, they are in the form of, this is in the form of CnH2n minus 2. So CnH2n minus 2, 18, 20 minus 2. CnH2n minus 2. So what is the name of these homologous series? They are called alkynes. They are called alkynes. Go to the second compound. Second compound B. So compound B. This is compound A, first one. Now compound B, formula C18H36. C18H36. See the relationship. 18 carbon atoms, 36 hydrogen atoms. So what is the relation? When you double this 18, 18 twos are 36. So this equation, this formula, they are in the form of CnH2n. If it is CnH2n, they belongs to the homologous series, that is alkenes. They belong to alkenes group. Alkenes, that is the homologous series. Name the homologous series. So first one is alkyne family, second one is alkene family. We'll move to the next question. So the question is, write the name and structure of an aldehyde. Write the name and structure of an aldehyde with 4 carbon atoms in its molecule. With the 4 carbon atoms. 4 carbon atoms. We have to write name of the compound. We have to write structure. So how many carbon atoms are there? There are 4 carbon atoms and it is aldehyde. This is aldehyde. So first write 4 carbon atom. 3, 4. Aldehyde, functional group of aldehyde CHO, that is last carbon, you write the functional group, that is C double bond O H or CH double bond O. Anyway you can write this CH double bond O. This is the functional group of the aldehyde. Now complete hydrogen. 1, 2, 3, fourth bond, 1, 2, 3, 4, 1, 2, 3, 4. For this carbon already 4 bonds are present, 1, 2, 3, 4. So this is the structure. Structure and name. What is this name? What is the name of this compound? There are 4 carbon atoms. If the carbon atoms are 4, name is butane. But you have to remove the letter E. Aldehyde, you have to add the suffix Al. So what is the name of this compound? Name of this compound is butanol. The compound with the 4 carbon atoms with the aldehyde as the functional group, that is the name of the compound is butanol. Move to the next question. Write the number of covalent bond in ethane. Write the number of covalent bond. Write the number of covalent bond in ethane. Ethane. So this question is there in the multiple choice also. The number of covalent bond present in ethane. So to count the covalent bond, first write the structure of ethane. There are 2 carbon atoms. This is alkane. So all single bonds around the carbon. Carbon form a single bond with the hydrogen. This is the structural formula or the structure of ethane. Now count the number of covalent bonds. 1, 2, 3, 4, 5, 6, 7. So all together how many bonds are there? All together 7 bonds. With the carbon, single bond. With the carbon and hydrogen, 6 bonds. 1, 2, 3, 4, 5, 6. Carbon and hydrogen. Between carbon and hydrogen, there are 6 covalent bonds. Between carbon and carbon, there is a single or there is one covalent bond. Altogether 6 plus 1, 7 bonds. So how many bonds are present here? There are 7 covalent bonds. 7 covalent bonds in ethane. Ethane has 7 covalent bonds. We'll move to the next question. Name the functional group present in functional group. Question is, write the functional groups. Name the functional groups or write the functional groups present in CH3CO CH3, CH3CO CH3, and name this compound. What is the name of this compound? So first identify which functional group is present. This molecular formula is given CH3CO CH3. So you can say here functional group CO, which is present in between 2 carbon atoms. There are 2 carbon atoms at the left side as well as in the right side, and middle one more carbon atom and oxygen CO. So we have studied functional groups where CO is present. CO as the functional group, that is a functional group of ketones. The name of the functional group is ketone, CO. If you want to write the structure, you can write the structure C, C, C. This is O, C double bond O. Here 3 hydrogen atom and this side 3 hydrogen atoms. That is CH3, CO, CH3. Functional group present is ketone. What is the name of this compound? There are 3 carbon atoms. So the name can be given as propanone. The name of the compound is propanone. Propanone is the given name. That is the compound which is given. Its name is propanone. Functional group is ketone. We'll move to the next question. The question is like this. The molecular formula of the first member of a certain group of organic compound is CH2O. Write the name and molecular formula of the third member of this group. The molecular formula of the first member of certain group. Molecular formula is given CH2O. I will write the question. The molecular formula. The molecular formula of first member of a certain group of organic compounds is CH2O. write the name and molecular formula of the third member. Write the name and molecular formula. Molecular formula of third member. Third member of this group. What is the general name for this group of compounds? And also, what is the general name? What is the general name? Okay, see the question. The molecular formula of first member of a certain group of organic compound is CH2O. So this CH2O will write in the form of structure. How we can write in the form of structure? CH2O. So C, 2 hydrogen atoms, I am writing CH2, and here one oxygen is present. So if I write single bond with the oxygen, I get only 3 bonds. To complete the valency of carbon, I have to write here double bond. So between carbon and oxygen, if you write a double bond, then valency of carbon is satisfied here. So altogether, around the carbon, there are 4 covalent bonds. So here, the compound formed, you can see the structure CHCHO. So this functional group is present. Which functional group? The CHO. This is the aldehyde group. So this functional group represent the given compound is aldehyde. So what is the question is asked? What is the general name of these compounds? General name is aldehyde. General name given aldehyde. One more question is there. Write the name and molecular formula of third member. Third member. First member, first CHO, first compound. This is the first compound. It is called methanol, or it is also called formaldehyde. Methanol or formaldehyde. Second compound comes here. First H. Second compound comes CH3CHO. So the third compound is C2H5CHO. So what is the question is asked? Write the name and molecular formula. This is the molecular formula of third compound. What is the molecular formula? C2H5CHO. First compound HCHO, CH3CHO. Third compound C2H5CHO. So the molecular formula of third compound C2H5CHO. What is the name of this compound? There are altogether 2 plus 1, 3 carbon atoms. So name of this compound is propanol. Propanol is the name of the given aldehyde, given compound. That is the third member of the family of aldehyde. First member methanol or formaldehyde, second one ethanol, third one propanol, as in the same way butanol, pentanol, hexanol continues. So this first compound methanol is also called formaldehyde. One more name of methanol is formaldehyde. Third member propanol, its formula C2H5CHO. We'll move to the next question. The question is, write the name of the following compounds. Name the following compounds. In that A, HCOOH. Second compound CH3CO, CH2CH3. Third compound CH3CH2-C triple bond CH. Name these compounds. So which is this first compound? What is the name of first compound? In the first compound we can see here COOH. COOH, this is the functional group of carboxylic acids. Here only one carbon atom is present. So HCOOH. This formula represents which compound? This is methanoic acid. Methanoic acid. Methanoic acid. This is the formula HCOOH. Come to the second one. CH3CO. So if CO is present at the middle, it may be after first and second, it may be between first member and second member, or the CO, it contains, it is present in the second position, third position, fourth position, etc. But it should not come in the beginning as well as at the end. So in between anywhere we can write this CO. If CO is the functional group, that is the functional group of ketones. Now, what is the name of this compound? To write the name, first count the carbon. 1, 2, 3, 4 carbon atoms are present. If there are 4 carbon atoms, name is butane. So from butane you have to remove the letter E. This is ketone, so you have to add the suffix ONE. What is the name of this compound? That is butanol. Now go to the last one. See the compound CH3, CH2, C, triple bond CH. So when triple bond comes, which compounds? Triple bonds you have studied. Triple bonds, that is the between carbon. If triple bonds are present, we call them as in general alkynes. So this is an alkyne. But what is the name of that compound? So alkyne family, there are 1, 2, 3, 4 carbon atoms are present. Therefore, the name can be given butane. Butane is the name. You can write this using structure in the form of structural formula. CH3. So 1, 2, 3. Second CH2. Here 1. Here 1. Next C, triple bond. Triple bond C. Here for this carbon 1, 2, 3, 4 bonds are present. So no need to write any hydrogen. For this carbon 1 H, because this side 3 bonds. So here 1, 4. Together 4 bonds. 1, 2, 3, 4 bonds completed. So carbon balance is satisfied. So name of this compound is butane. Butane is the given compound. First one is methanoic acid, second one is butanol, and third one is butane. Okay students, now we will study some of the important carbon compounds. They are ethanol and ethanoic acid. First one is ethanol. Ethanol. What is the formula of ethanol? CH3, sorry, C2H5OH. So this C2H5OH can also be written as, it can also be written CH3CH2OH. So we have to, if you split C2H5O, this can be written CH3CH2OH. So in this way we can write ethanol, C2H5OH. So if you take C2H5OH, it is one of the important carbon compound, ethanol. So ethanol is mainly used, it is a very good solvent, so it is used in most of the alcoholic drinks. We can say in all the alcoholic drinks, ethanol is used. It is an active solvent which can be used in the alcoholic drinks. So in addition to that, ethanol can also be used in the medicine such as cough syrup, in tincture iodine. Ethanol is used in these medicines. So these are the main uses of ethanol. So now we will go to the chemical properties of ethanol. Very important. Chemical properties of ethanol, in the sense how ethanol reacts with the other reagents. In that first one is reaction of ethanol with the sodium. Reaction with the sodium. with the sodium. How ethanol react with the sodium? Ethanol, I write this as a CH3, CH2OH. Ethanol react with the sodium. Sodium is Na. It gives CH3, CH2OH plus Na. It gives. So you write this together. CH3, CH2, and in this H place what comes? Na comes. That is CH3, CH2ONA, or we can write it as C2H5OH. We get here C2H5ONA. So what is this C2H5ONA? This is sodium ethoxide. Sodium ethoxide with the liberation of hydrogen gas. So which gas is liberated when ethanol react with the sodium? When the ethanol react with the metal, that is very active metal, that is sodium. Ethanol react with the sodium to form sodium ethoxide along with the liberation of hydrogen gas. Now here is a question. How to test the liberation of this hydrogen gas? What is the test for the hydrogen gas? How we can test liberated gas is hydrogen. So we have already studied in acid, base and salt lesson how to test hydrogen gas. Hydrogen gas is passed through the soap solution. Soap bubbles with hydrogen is formed. When you bring a burning candle near that soap bubbles, so that bubble burst with the pop sound. Pop sound you can hear. It bursts with a pop sound. So using this test we can say the liberated gas is hydrogen gas. Hydrogen gas is passed through soap solution. We get the bubbles of hydrogen gas, the soap bubbles which contains hydrogen gas. Burning candle, when it is brought near these bubbles, that bursts with the pop sound. This indicates that liberated gas is hydrogen gas. Using this we can say the gas liberated is hydrogen. So when you balance this reaction, when you balance, you will get here 2 comes, here 2 and here 2. H2 gas is liberated. So here you have to write 2. When ethanol reacts, it's a very important reaction. Ethanol reacts with the sodium metal. It produces or it liberates hydrogen gas along with the byproduct sodium ethoxide. Now we move to the second reaction, that is reaction with concentrated H2SO4. What is this H2SO4? Sulfuric acid. What is the reaction between sulfuric acid and ethanol? When ethanol is heated, ethanol CH3, CH2OH, ethanol is heated with the concentrated, that is when ethanol is heated at a temperature of 443 Kelvin. 443 Kelvin. High temperature with the highly concentrated sulfuric acid H2SO4. So what happens when it is heated with sulfuric acid? We get an unsaturated compound. Which is that unsaturated compound? CH2 double bond CH2, or you can write it as C double bond C H2. So which is this compound? What is this compound? C double bond C, C2H4. What is the name of this compound? It is called the ethene. Along with the liberation of water, H2O. Along with the liberation of water. So this reaction is called as dehydration reaction. Dehydration. Why the reaction is called dehydration reaction? Because during the reaction, removal of water takes place. Water is removed here. Therefore, the reaction is called dehydration reaction. In this case, this concentrated sulfuric acid acts as dehydrating agent. Dehydrating agent. What is dehydrating agent? The agent which removes oxygen. Agent which is responsible for the agent which removes water, or the agent or the substance which is responsible for the removal of water, we call them as dehydrating agents. So in this case, in this reaction, concentrated sulfuric acid, the role of concentrated sulfuric acid, it acts as a dehydrating agent because it removes water. From ethanol, water is removed. Removal of water takes place and we get an unsaturated compound. This is ethanol is saturated one. All single bonds present in ethanol. But ethanol, that saturated compound, converted into unsaturated compound when it is heated with excess concentrated sulfuric acid at a temperature, high temperature, that is 443 Kelvin. It can be also called a hot concentrated sulfuric acid. When it is heated with hot concentrated sulfuric acid, we get an unsaturated compound along with the removal of water. Therefore, this reaction is called dehydration reaction, and the role of sulfuric acid in this case is it acts as dehydrating agent. This is the second chemical property of ethanol. Ethanol reacts with the sodium metal. Ethanol reacts with the concentrated sulfuric acid, hot concentrated sulfuric acid. So both are very important reaction. Now we will solve some of the questions related to these reactions. Questions are like this. First question is, write the name and structural formula of the compound. Write the name and structural formula. Write the name and structural formula of the compound formed. Of the compound formed when ethanol is heated at. When ethanol is heated at 443 Kelvin with excess concentrated H2SO4. What is the role? What is the role of H2SO4? This is the first question. So how to solve this question? What is the question asked? Write the name and structural formula. Name you have to write, structural formula you have to write. When ethanol is heated at 443 Kelvin with excess concentrated H2SO4. So when ethanol is heated with excess concentrated H2SO4, we get compound ethene. So name you have to write. The compound we are getting, first question for that answer. Ethene is the compound form. It's a structural formula. What is the structural formula of ethene? You have to write structural formula. Structural formula ethene, C double bond C, H, 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 H. So this is the structural formula of ethene. One more question is there. What is the role of H2SO4? So what is the role of sulfuric acid here? Sulfuric acid acts like a dehydrating dehydrating agent. So you have to answer to the point. First question, name, structure. Name is ethene, compound form. It's a structural formula of ethene with the double bond. And role of concentrated sulfuric acid. Concentrated sulfuric acid act like a dehydrating agent. We'll move to one more question. Question is like this. A compound X. Second question. A compound X on heating with a compound X on heating with concentrated H2SO4 at 443 K gives an unsaturated compound. Gives an unsaturated compound. Why? X also react with sodium metal to evolve gas Z. Z gas is evolved. Identify X, Y, Z. Write the equation of the chemical reaction. Write the equation of the chemical reaction of formation of Y, and also write the role of sulfuric acid in the reaction. Sulfuric acid in the reaction. So we'll solve this problem step by step. So what question says, a compound X on heating with concentrated H2SO4 at 443 K. So when you see this 443 K concentrated H2SO4, so you have to write what is that reaction? C2H5OH or CH3CH2OH react with the sulfuric acid H2SO4 concentrated, heated 443 K. It gives an unsaturated compound. So this is X react with highly concentrated sulfuric acid heated at 443 K. We get an unsaturated compound. So the compound we are getting, that is ethene, that is called Y. X is C2H5OH. C2H5OH also react with the sodium metal plus sodium metal gives gas Z. So here two byproducts, one is C2H5ONA and with the liberation of gas, that is hydrogen gas. Identify, this is called Z. So X, ethanol, Y, product we are getting C double bond C H2, that is C2H4, which is ethene. Here water is also liberated. That X also react, ethanol also react with the sodium metal. We get sodium ethoxide and gas is hydrogen gas. It liberates gas Z. Identify X, Y, Z. So you have to write X answer. X is, what is X? X is C2H5OH. Identify X. You can write C2H5OH or you can write ethanol. X is ethanol. Then what is Y? Y is ethene. Ethene you can write or you can write C double bond C H2 H2. Then what is Z? Z is, it is a gas, hydrogen gas. Hydrogen gas. Now, next question. Identify X, Y, Z. Write the equation of the chemical reaction of formation of Y. Formation of Y, which reaction? This reaction. This is formation of Y. Ethanol heated with concentrated H2SO4 at 443 K. We get ethene with the liberation of water, with the removal of water. This is the equation. Chemical equation you have to mention this one. Then, what is the role of sulfuric acid? What is the role of this sulfuric acid? Sulfuric acid act like H2SO4, that is concentrated sulfuric acid, act as a dehydrating agent. So in this way you have to solve. Part by part you have to read the question, you have to understand, and step by step your answer should be there. So here chemical reaction you have to mention. This reaction should be there in your answer. That is the reaction of ethanol with sulfuric acid to give unsaturated compound, that is ethene. This is the chemical reaction asked. First X is ethanol, Y is ethene, Z is hydrogen gas. This chemical reaction and role of sulfuric acid. Sulfuric acid act like a dehydrating agent. Now we will move to the next question. So in the question paper, question is given like this. What are structural isomers? Structural isomers, same as isomers. So what are structural isomers? The compounds with the same molecular formula, with the same formula or same chemical formula, but they have different structures. They have different structural formula. They are called as isomers. Name the first member of alkane that shows structural isomerism. So the first member of alkane which shows structural isomerism is butane. There is no isomers for methane, ethane and propane. The structural isomers starts from the compound butane. So the first member of alkane which shows structural isomerism is butane. One more question. The functional groups present in propanol and propanal respectively. The functional group present in propanol and propanal. Propanal. So only one letter difference. This is O, this is A. Propanol, propanal, functional group. If OL in the sense alcohols. What is the functional group of alcohols? OH is the functional group of alcohols. Then AL, propanal, aldehyde is the functional group. What is the functional group of aldehyde? Functional group is CHO. CHO is the functional group of aldehyde. So OH and CHO are the functional groups. If the question is asked, propanol and propanol, name the functional group present in these compounds. If the question is asked, name in the sense, this is alcohol, this is aldehyde as the functional group. In propanol, functional group present is alcohol. In propanol, functional group present is aldehyde. The question is asked, write the functional group. Write the functional group. This is functional group OH and CHO. So here is a question, multiple choice question. The question is like this. Ethanol reacts with sodium metal to form products. Are dash. Ethanol reacts with the sodium metal to form product. Which are the product form? Ethanol, C2H5ONa, sorry, C2H5OH, react with the sodium metal. We get the product C2H5ONa with the liberation of hydrogen gas. Hydrogen gas is liberated. Reaction of ethanol with the sodium. So which are the product from the C2H5ONa H2. Options given: CH3ONa plus H2, CH3COONa plus H2, CH3COOH plus H2O, C2H5ONa plus H2. So C2H5ONa plus H2. One more question. The alcoholic drink contains alcoholic drinks contains option A CH3OH, B CH3COOH, C CH3COOH3, D CH3CH2OH. So alcoholic drinks contains what? Most of the alcoholic drinks contains ethanol as the ingredient. So which is ethanol formula here from the given option? Ethanol, its formula C2H5OH. It can also be written as CH3CH2OH. So alcoholic drinks contains CH3CH2OH. Now we will move to the next important carbon compound, that is ethanoic acid. Ethanoic acid is also called as acetic acid. Ethanoic acid or acetic acid. What is the formula? CH3COOH. This is acetic acid or ethanoic acid. So acetic acid, 5 to 8% solution of acetic acid with water, we call it as vinegar. It is a best preservative. It can be used as preservative in pickles. Well, we'll move to the chemical properties of these ethanoic acid. When ethanoic acid, I write this ethanoic acid CH3COOH, ethanoic acid CH3COOH, this is called ethanoic acid. When it reacts with alcohol, which alcohol? Ethanol, that is C2H5OH. I write it as C2H5OH, or in the textbook it is given CH3CH2OH. In this way also you can write. When alcohol react with carboxylic acid, we get, what we are getting? We are getting ester plus water. Ethanoic acid or acetic acid react with ethanol. It gives this H and this OH. They combine together and we get HOH, that is H2O, water. Remaining product, which are the remaining product? CH3COO, and this adds here C2H5. In your textbook, this compound is given as CH3C double bond O C2H5. In this way it is given. So why this C double bond O? This is carboxylic acid. Carboxylic acid, usually how we are writing? C double bond O OH. This is carboxylic acid. So in this carboxylic acid CH3COOH as the functional group. So this is carboxylic acid. Which carboxylic acid is particularly acetic acid? Acetic acid react with the alcohol, that is ethanol. We get a compound called CH3COOC2H5. It can be written as CH3C double bond OC2H5. So this compound we call it as ester. They are called esters. It is called ester along with the water. The reaction, this reaction is called as esterification reaction. Esterification reaction. Why it is called esterification reaction? Because during the reaction esters are formed. So the reaction is called esterification reaction. In general, what is esterification reaction? When a carboxylic acid, when an acid react with alcohol react with carboxylic acid, we get ester along with the water. This reaction is called esterification reaction, or we can say ethanoic acid or acetic acid react with ethanol. We get ester and water. This reaction is called esterification reaction. So esters are sweet smelling substances. They are mainly used in the perfumes as well as a flavoring agent. These esters are used. They are used in the perfumes because they have sweet smell. They are used in the perfumes as well as a flavoring agent. These esters are used. Now, when these esters react with, so what is that ester? CH3COOC2H5. Esters, when they react with an alkali, it may be sodium hydroxide or potassium hydroxide. When they are treated with sodium hydroxide, then what happens? This splits here, this OH combines with this C2H5, we get as a byproduct C2H5OH plus, what is the remaining byproduct? CH3COO, and this sodium adds here, that is Na. This is called sodium ethoxide. And this is our ethanol. Once again, we get ethanol using ester. Esters, when they are treated with NaOH, with the sodium hydroxide, we get sodium ethoxide along with the ethanol. Once again, we get ethanol in this reaction. This reaction is called saponification reaction. This reaction is called saponification reaction. Why this reaction is called saponification reaction? because the same reaction is used in the manufacture of soaps. Soaps are manufactured using this reaction. Esters are treated with an alkali. It may be sodium hydroxide or potassium hydroxide. We get here, when it is treated with sodium hydroxide, we get sodium ethoxide along with ethanol. So the reaction is called saponification reaction. When acetic acid is treated with ethanol, we get ester. When ester is treated with sodium hydroxide, we get once again ethanol. Ethanol can be obtained once again. So this reaction is esterification reaction. This reaction is saponification reaction. Differentiate between esterification and saponification reaction. Esterification reaction used in the manufacture of perfumes, or it can be used as a flavoring agent. The reaction is used in the perfumes, or it can be used in the flavoring agent. Saponification reaction is used in the manufacture of soap. This is the first difference. Second difference, reaction. You have to go to the reaction. What is esterification reaction? When ethanoic acid is treated, or when it reacts with ethanol, we get ester and water. This reaction is called esterification reaction. When ester is treated with sodium hydroxide or an alkali, we get ethanol along with sodium ethoxide. This reaction is called saponification reaction. Differentiate between esterification and saponification reaction. First difference, reaction itself, that is the reaction between ethanoic acid and ethanol to give ester and water is called esterification reaction. Saponification reaction, when ester is treated with the sodium hydroxide, we get ethanol with the byproduct sodium ethoxide. The reaction is called saponification reaction. Esterification reaction is used in the manufacture of perfumes. Saponification reaction is used in the manufacture of soaps. So these are the main differences between esterification reaction and saponification reaction. So while writing this esterification reaction, in the textbook, in the reaction itself given like this arrow mark. So what this arrow mark shows, both sides. One like this product, one in this way, reverse order. What it shows? It shows from the this acid, we are getting sodium, we are getting ester and water. That from these byproduct, when we are using ethanol and ethanoic acid, we get ester. But from the same ester, we get, it is possible to get alcohol. We are getting once again alcohol here. Therefore, the arrow mark which is given in this way, that is opposite way. One is, this is the product. One more way, this is the product, which shows from this we can get this as the product. By using this, we can get this as the product. That is the meaning of this arrow mark. So that is esterification and saponification reactions. Next reaction is reaction of ethanoic acid. Reaction of ethanoic acid. Reaction with Na2CO3, that is sodium carbonate, and NaHCO3, sodium hydrogen carbonate. How ethanoic acid react with the sodium carbonate and sodium hydrogen carbonate? Ethanoic acid, that is CH3COOH, react with Na2CO3, that is sodium carbonate. We get product CH3COO, CH3COO, and in this place this sodium comes, that is CH3COO Na with byproduct water plus carbon dioxide. So this is Na2, here 2, here 2. CH3COOH, that is ethanoic acid, react with sodium carbonate, we get product sodium ethanoate with the liberation of carbon dioxide gas. In the same way, ethanoic acid CH3COOH plus NaHCO3 sodium hydrogen carbonate it gives CH3, same thing, COONA plus H2O plus CO2. So which gas is liberated when ethanoic acid or when acetic acid, when it reacts with sodium carbonate, either sodium carbonate or sodium hydrogen carbonate, they give these byproducts along with the liberation of a gas. Which gas is liberated? Carbon dioxide gas is liberated. So how you will test? How to test? What is the test for the identification of carbon dioxide gas? When carbon dioxide gas is passed through lime water turns milky. This is the test for the identification of the carbon dioxide gas. Carbon dioxide gas is passed through lime water turns milky. So by this way we can say that liberated gas is carbon dioxide gas. So this reaction is the differentiate, it is one of the best reaction to differentiate this acid, that is acetic acid and ethanol. Ethanoic acid and ethanol can be differentiated using this test. Experimentally, the acetic acid as well as ethanol can be differentiated. We can identify using this test because acetic acid react with either sodium carbonate or sodium hydrogen carbonate. They liberate carbon dioxide gas. But ethanol, when ethanol is made to react with sodium carbonate or sodium hydrogen carbonate, there is it is impossible to get carbon dioxide gas. Carbon dioxide gas is not liberated. So this is the experimental test. Experimentally, we can differentiate ethanol as well as ethanoic acid.